Hello, everyone. Welcome to our webinar today. Thank you so much for joining us. My name is Corey Brickman, Marketing Programs Manager here at Neo4j, and I'd love to welcome you to our webinar today on Graphs for Enterprise Architects. Today, we are joined by Jesus Barrasa, part of our field team here at Neo, and we are also joined by Mark Needham, part of our software engineering team. They have an excellent presentation queued up for you today. So a few housekeeping notes before we all get started. You may enter any questions you have at any time throughout the presentation using the questions box in your GoToWebinar control panel, and we will have a live Q&A session right at the end of the presentation. You'll also be receiving a follow-up email tomorrow with the slides as well as a recording of this presentation, should you like to view it again or share it with any colleagues. With that being said, we will go ahead and get started, and I would like to introduce to you Mark and Jesus.
Hi, thanks, Corey. So this is Mark.
Hi, Jesus here.
And so as Corey said, so we're going to be doing an introduction to graphs, specifically aimed at enterprise architects. Here's a brief outline of what we're going to do. So if you kind of lose track at any point, this is your roadmap to what we're going to do. So we'll kind of start off with a bit of an intro to graphs and Neo4j in particular, and what is this thing? Why would I be interested in it? We'll then do a bit of a bridging exercise where we look at how does this tie in with what enterprise architects often have demands placed on them, and how does it tie in there? We'll have a little bit of a look at Cypher, which is Neo4j's query language, and then the main part of the talk we'll be looking at architectures that we've seen people using Neo4j for, and we'll show you some examples of the main ones we've seen, and then we'll finish up with some examples of integration tools that people have written, how they integrate this with other parts of their ecosystem, and we'll also explain other parts of the Neo4j ecosystem. And then, as Corey mentioned, if you've got any questions, send those in on the question box, and we'll handle them at the end. Okay, so let's get started. So how did we end up in a talk about graph databases in the first place? I guess if you're like me, the first few years of your career, so for me it was about 6 or 7, when you were building some application, and often I suppose it would have been a web application in the last century, and you needed to store data somewhere. The only real choice you had was to put it in a relational database, and it was just a choice of, well, which platform are you on, which one are you going to use? So are you on the Microsoft stack, or are you on another one? And we kind of got to this point probably about 6 or 7 years ago where NoSQL came in and people started trying to work out, well, is there a way that we can actually solve these problems that perhaps a relational database isn't working well for? So it works well for some problems, but there are other ones where people were having challenges. And so the way the databases, the NoSQL databases have gone is 2 ways. So you can either go the left side of the fork and denormalize the data, and so you start storing more aggregates of your data, so perhaps you store documents or you store key values. Then you've effectively simplified the data model a bit, and it's very easy to do lookups on that and just get the whole result set and put it, for example, on the page. And if you want to drill into those data sets, you would often be using something along the MapReduce lines. On the right-hand side fork, we actually choose to make the model even richer. So rather than, for example, having the join at runtime, we actually build that into the model that we store. So for example, we name the relationships rather than inferring them. And so this is the side that we're going to live on. And this allows you to express your domain a bit more clearly, as we'll show with some examples. And the way that you find insights into your data is by doing what are called graph traversals. And we'll show a few examples of those as well. So let's just do a quick introduction to Neo4j. So Neo4j is a graph database, and it's the most popular one. So this is these screenshots are taken from a website called DB Engines, and so you can see so Neo is the most popular graph database. And we'll get into what a graph database is in just a few seconds, in case you haven't come across that. But just this month, it's now reached into the top 20 databases in any model
category, right? Not just graph databases, but including relational, including document, including all sorts of data stores. So yeah.
Yes, this is a pretty nice milestone to have reached. So we'll just do like a brief history of Neo in case you haven't come across it before. So it uses what's known as a property graph model, which we'll get into. So it's used that since the first version in 2000, and sort of over time we've had customers using this since around 2003. It's been open sourced since 2007, and there have been various rounds of funding over the years. We picked up our first global 2000 customer, I suppose it would be about 7 years ago now. Cypher, the query language, was introduced in 2011, and then you can see there are a few other events, and the most recent technical one being the introduction of labels into the model, which we'll also see with some of our examples. I'm kind of now at the point where so there's 150 customers as of a couple of years ago. It's now over 200. And there are lots and lots of events and lots of people downloading the software. Okay, so what is a graph? So it's a graph database, and so people's first impression when they hear, oh, it's a graph database is, cool, it's going to generate some pretty pictures for me. And if you Google for the word graph, you probably come across lots of pictures looking like this. But these are not really the graphs that we're thinking of. These are charts for the purpose of this presentation. The graphs that we have in mind look much more like this. So this is an example of a graph of meetup.com data. And there are a few words that need to go into your glossary so that that would be helpful to remember for the talk. So if we go from along the top, so we've represented a location. So that would be like the equivalent of a record in a relational database. We're representing that's known as a node. And then we've over here in the yellow we've got a group, which would be another node or another record, and we can connect them together. So those are two nodes, and we connect them together and express, well, what's the link or what's the relationship between them, which in this case is located in. And then we've got different relationships between different types of data. So for example, stats has a has members relationship with group. And then we've also got properties. So for example, the stats nodes have like a count, saying effectively counting how many instances there are. And then we've also got those on the topic, the groups and the locations. And those names there, those are the labels. So for example, that node there has a topic label, and that allows us to distinguish what type of node is it, and allow us to quickly go and look those up if we wanted to. So that's a brief intro to graphs in general. So now we're going to have a look. Well, how do we bridge this? We've got this database, and we can see it allows us to express the domain. In this case, Meetup. But how does that tie into enterprise architecture demands?
Right. So yeah, we'll get into more details about Neo and graph databases. But let's look now a little bit at which are some of the typical requirements on an enterprise architects. What type of challenges do they face on the daily jobs? So the three of them are the ones you're seeing on your screen. So it's operational efficiency, flexibility, and time to market. And we're going to see that some of the characteristics of Neo4j and graph databases are particularly adequate to tackle these requirements. So, right, the first one that we're going to talk about is flexibility. And in particular, the first point is this idea of whiteboard-friendly modeling, which is characteristic of graphs, and as sorry. As you can see, this idea basically reflects the fact that the logical model, the conceptual model that you draw on your whiteboard, is exactly the model, at least very close to the one that's physically stored in your graph database. And that has a number of advantages. I mean, first, of course, it reduces the gap between teams in your for example, between business and IT. So a graph is a model that very likely be understood by both managers and also IT people. So we keep getting this kind of feedback when we talk to users and customers. So we see that that simplifies, and we'll reiterate this idea, the communication between teams. So this whiteboard friendliness, this intuitiveness of the model is one
Yeah, so we've sometimes been at customers where a not very non-technical user will come up to you and say, "Oh, I really like this this database because I can actually go and read the queries that people are writing and what they when we talk about the problem, the language that we use when we're talking about it is exactly the same as what I see in their code or in the sketches that they come up with. And it seems to be quite a feature that people quite like. That there's no technical terminology that they don't understand getting mixed in.
Traditional gap between your conceptual model and your physical implementation. So this translation in the case of the relational model to tables that always build this wall between IT people or DBAs and the rest of the world. So that kind of in a way disappears with graph modeling and graph databases. Right. The next one would be the optionality of the schema. So Neo falls as Mark mentioned before under the NoSQL category, where you kind of are free in the sense that you don't have to define your schema up front and then make your data match that schema and otherwise not be accepted by your store. So in that sense, a NoSQL database and in particular would be easy in terms of ingesting data, and that adds of course flexibility. That's again optional. So we've been getting this requirement from our users that sometimes you want to establish some kind of control and define some degree of constraints. And what you're seeing in front of you is some of these possibilities. So you can define constraints, for example, of unicity ones, like the one you see in the first Cypher statement. So we're specifying there that the ISBN would be a primary key, if you want to call it like that, of the book node. And similarly, we can define existential constraints, so we can specify that certain properties are required in a node, for example. So you have the both options. So you can be absolutely free, or you can specify some constraints.
Yeah, and so what tends to happen is that when people start out on their graph project, at the beginning they're like, oh, I want this to be completely free. I want to just be able to put whatever data I want in. And as they've become more comfortable that the model seems to fit the problem, then they'll move towards the more wanting to put a bit of scheme around it. And at the moment, as Hazer said, there's a couple of constraints, and I think the intention will be that as the product goes over time, we'll add in more of those to help people describe the invariance of their domains. For example, perhaps having a constraint that would allow you to say, well, if you can only have a relationship of a specific type if one of the nodes has a specific label, for example. But at the moment, no, these are the ones that exist.
Right, and yeah, a third point in terms of flexibility is the kind of spectrum that Neo4j covers. There's traditionally been this division between what's transactional and operational systems and data stores, and then the more analytical ones, where we're more targeted to its more offline or more analytical queries, and we see that Neo is being used in both senses. So it can be used, of course, because it's asset compliant as a transactional data store, but it also enables querying of data according to many dimensions. Right. So in terms of operational efficiency, well, one of the key reasons of adoptions is the kind of performance that you get from querying the graph. So and because Neo4j is a native graph database as opposed to a graph analytics platform, if you want to call it like that. So because data is stored natively as a graph, we do make connections between nodes explicit as basically pointers between them. So we translate this problem of data joining, which introduces performance issues, into what basically pointer chasing. So that produces orders of magnitude improvements in performance. And also because it's a highly normalized model, we tend to have very compact ones and reduced duplication, which also implies savings on hardware costs as well. In terms of scaling, I mean, can go both in horizontal and vertical scaling. So you can add processors to get better performance, but you can also have multiple nodes working on a cluster deployment to be able to provide high capability for high read volumes as well. It's important to say that it's a mature product. So Mark has talked about the history of Neo4j, but it's been in production for over 10 years now, and there's a significant number of enterprise subscription customers. And well, finally, probably worth mentioning that we provide professional support and best practices on top of the huge community of users that you can find on the different channels. We'll talk about that later as well. Right. In terms of the time to market, which was another of the requirements that we mentioned that enterprise architects face on a day-to-day basis. So because of the nature of the not schema-less nature of the graph model, it lends itself to this agile and incremental delivery mode. So a graph model is naturally adaptive. So we keep seeing that our users start with a particular use case, but that doesn't stop them from growing the graph incrementally from there. So you try to answer the questions that you have initially, but then you make your model evolve as new requirements arise, and that this inclusion of new information is kind of a natural thing for a model like the graph model, where you obviously don't need to design to upfront the whole what your system is going to look like in its entirety. So you don't need to invest this initial upfront modeling effort on as you would do with traditional relational databases.
And one of the other nice things is that you can start out with, let's say, quite a simple model, and then if you decide at some point, oh, actually, I want to change that a bit to help me answer the next requirement, it's very easy to use the query language to go and refactor that model. So migrating a data model doesn't become such an issue as it often is working in a relational system. And as Jesus said, there's no need to design the whole schema, if you like, up front. Modeling incrementally is much more the way we see people going, and it fits in quite nicely because you often don't know, well, what exactly do we want to build up front. We often start with just a small idea and it evolves over time. And we found people are able to deliver their products very quickly by sort of combining the graph into this delivery model.
Right, and just reiterating again this idea that we mentioned before, because of this intuitiveness of the graph model, we see that this traditional gap between business and IT is reduced significantly, but also the communication between teams, and that's reflected also in the fact that simplifies and reduces the time required to ramp up new project members. Again, because typically code is easier to read. There's
less of it.
There's less of it, exactly. Less.
Yeah, so one of the examples that we'll look at in just a few slides' time, actually managed to move from a SQL query which was several hundreds of lines and required really quite intense concentration to understand what was going on, to something which is obviously much smaller, say between 7 and 10 lines. And then for someone new coming in, even if they don't know anything about the domain or the tooling or anything, at least that bit of the stack is quite easy to ramp up on. Which leads us to our last point on the time to market section. So this is I suppose similar to the previous, so some of the previous points Jesus has made, and this is the lowering of modeling impedance. And so this time we're going to have a quick look at an example comparing relational and graph models to hopefully make it a bit more concrete in your head. How does this work? So on the left side, we've got an example of a relational model. And as you can see, the idea here is that we're modeling a friends graph. So imagine, say, a Facebook, or you could change a few of the words and perhaps it becomes a Twitter graph instead. And so on the left side, we've got our relational model. Perhaps we've got a person table, and as you can see, we've got a person, Andreas, in there, and then we've got a connecting table connecting that, and then maybe we've got perhaps it's either a friends table or another person table on this side. And so we've had to pull out 3 tables for that. Perhaps we've had to define some primary keys and foreign keys, connecting them together. And so that's our relational model. On the right-hand side, we've got the graph model, and so you can, hopefully you can see this is a little bit simpler in design. So we're able to just to define what is the relationship. So in this case, we've called it nodes, and we can just have a direct link from Andreas, for example, to Tobias, to Mika, and to Delia. And there's no need to create a join table to do that work. We can just connect the nodes directly. And then the other thing is, let's say that's our model. So what does it look like in the Cypher query language? So Cypher is Neo4j's query language, and if you want to have a bit more detail on that, you can if you search for Open Cypher, there's a website sort of describing more where the language came from, what it looks like, and so on. But for now, we'll just have a quick look at some simple queries showing how might we query a data set. So effectively, we're doing a read query, and so we start with the keyword match, and then we describe a pattern that we want the query language engine to go and find for us. And we start off on the left-hand side. So we've got a person. So the person is Dan, and so that whole thing is a node. And imagine that's like an ASCII art drawing of the picture that's just above. So we've effectively got our little circle for Dan. Then on the right-hand side, we've got another one for Anne. And then in the middle, we've got a relationship representing, in this case, the relationship is loves. So Dan loves Anne. So that's how you might describe it in English. And then you can see match person Dan loves person Anne. And then the other things that we've got in this query are we've got a label. So we're saying that person, which has the property Dan, property name Dan, has the label person, and equally on the other side, Anne is a person and has the property.
Yeah, and well, what Mark's describing is the graph pattern part of the query, but for those of you who are familiar with SQL, I mean, in structure it's relatively similar. So you would have this pattern part, but there will be a filter part with the where section where you can apply filters to your results, to your query results, and similarly a projection part where you would specify which bits of the graph you want to return. So yeah.
And so let's have a quick look at an example of what Jesus was describing. We'll do a little bit of a comparison of what might it look like in SQL and what would it look like in Cypher. So let's say we've got a organizational hierarchy graph, and it happens to store the reports. So for example, who's your manager, who's their manager, and so on. What we want to do is find all the direct reports and how many people they manage, and we're going to go 3 levels. So let's say it's a reasonably big company, so they've got a few levels of hierarchy. So we had a go at doing this in SQL, and so if you were writing SQL, you might end up with something like this. So the tricky bit is that we kind of need to go to multiple levels with our join, and this is the type of query that's really, really easy to do in Cypher. So we'll just go through it. So effectively, the query is centered around John Doe. So John Doe is the boss in this example. So we narrow in on John Doe. So the query language will start there, and then we follow down up to 3 levels, all the people that John Doe manages, and so that will come back with a load of people. And then we go from those people and we find all the people that they manage, and so we get back all John Doe's reports down to 3 levels, and then all their reports down to 3 levels, and we can sum them up and see how many people report to each of the people who report to John Doe. And the nice thing is, if we decide, oh, actually 3 levels is not really enough, I want to do 4 or 5, all you've got to do is go and change that number. So you just change the 3 to a 4 or whatever number you want. If you wanted to do the same thing in SQL, that would be a little bit more difficult, and you probably have to go and probably copy paste one of those select statements and then union that onto the end of the query, which can become a little bit unwieldy if you don't really know exactly what the query that you want to write is.
Right, and yeah, again, we reiterate on some of the ideas. So this query language, as you've seen, is designed for connectedness. So it's based on the definition of patterns across your graph, and it's again intuitive and simple. I would say nature makes makes it easier to deal with, and of course involves less time writing, less code to maintain, less code to debug. In terms of optimization as well, it simplifies significantly. There's an interesting webinar actually by Mark from a couple of weeks ago on how to, is it about do's and don'ts and how to optimize your Cypher queries, right? So yeah. That's and again, it has an impact on teams in terms of, again, we've emphasized this idea several times: communication and just code understandability and ease as well, ramping up new project members. So, right, we're going to move now into well, the central part of the webinar, which is looking at these some of the typical architectures that we see our customers using when deploying Neo. So rather than looking at use cases, we're going to look at what the solutions look from an architectural point of view. And we've identified these three. I mean, there might be more, but in initial analysis, we find these as three quite differentiated ones. First one, we call it primary store, and it's this case where Neo, the graph database, becomes the primary store for a solution. So it's not like a replica or a parallel one that runs with another existing or legacy data store. So it typically takes both reads and writes, being the primary backend for a solution. The second pattern is where it acts as a secondary store, and for example, it's used for a specific need or for a specific use case, but it still takes its data from the primary store, which is typically a relational one. And in this case, I mean, the workload would be mostly reads and scheduled batch updates. The third one is where Neo is used as the hub for integration of data from different sources. It will be, again, some kind of secondary store, but we find it kind of differentiated from the other case because it's used in this context of integration, bringing in data from different sources and adding the integration logic on it. Right. So the first one, and we're going to look at it with an example. So there's Telenor. Is a mobile operator from Norway, I believe, so Scandinavia. And the problem that they had is they needed a system to control, to manage access to the resources, to control identity and access management. And what they needed to do is compute who could access to what resources in real time. So it's about resource authorization. And the problem they were finding is that it was taking up to 20 minutes for the largest customers. And you can imagine that the resources are complex structures that can typically organize in hierarchies. And even customers are also organized in complex structures, like virtual being part of organizations that are themselves part of other organizations after some mergers and acquisitions. So you have two complex structures that you have to align, and that was taking a long time. So the solution they were finding was to pre-calculate these access control, these access permissions, and caching those. The problem obviously is that wouldn't take real-time changes, and you might be working on stale data. And the architecture that they had in place was this middleware service that would control access from a number of channels, up to 42, as you can see in the diagram. And that was taking around 500 requests per second. And this system, this middleware service, was backed by a relational database, Sybase in this particular case, and it was controlling access to these 35 systems in the backend. And what they did basically is they replaced that with Neo so it is this primary data store case where Neo completely replaced the relational store. And the results that they achieve is that the response times were dramatically reduced to seconds and even milliseconds. And again, this idea of code maintainability, so it was significantly improved, and they could keep the permissions up to date. So it was updated as being the primary store, and that way they didn't need to cache anymore and would have access to the actual permissions without working on stale data. And we have a quote from one of the architects involved in the project. So it's one of the cases, and we see that being the same pattern in other customers. UBS did something very similar, so they were controlling access to the system, and they also migrated from a relational database-based solution with similar results. So the value was again real-time, both provisioning and deprovisioning, as was the case of Telenor. Worth mentioning that if this case sounds interesting to you, there's a video, probably linked from our website, otherwise easy to find in YouTube, where this architect describes the case and gives more details about the Telenor case. And another interesting one, completely unrelated, is the AYI stands for.
Are you interested? Yes, this is the Are you interested one. So this is quite. This is a little bit different. So this is a dating website, and they were using a relational database as well. And realized that they were able to get a lot more interactivity with their users and the application if they were able to suggest people that were within their social network. And so in particular, they wanted to be able to do queries where they found up to 3 degrees away from a person based on being able to load in part of the Facebook graph. And so again, the way they were able to address that was by using Neo4j to help them do those queries. And again, they found that the amount of data they were collecting was their metric of has this led to more interactivity, and they were seeing their database increase massively in size. And these are one of the biggest databases in terms of numbers of nodes and relationships that we've seen. So they're operating in I think somewhere around maybe 1.3 or 1.4 billion nodes, and at the last time I checked, it was about 14 billion relationships. Although I'm sure it's increased above that by now. And so with a lot of these use cases, there are white papers that you can go to the website to download, and perhaps we can also send a link for the Telenor video that Jesus mentioned on the email with the slides tomorrow. Yeah. But for now, let's have a look at our second case. So that was our primary store case. So that was doing reads and writes in real time, and we're kind of updating the graph in real time. Now let's have a look at another one. So this time we're looking at Shuttle and eBay, and they are our primary, our secondary. I was going to say our primary secondary store case. Which perhaps not the best wording.
Favorite one.
Our favorite secondary store case. And so the problem they were addressing here was that part of their service is allowing them to do delivery, effectively close to real-time delivery to e-commerce websites. And they wanted to be able to show the user, so effectively the user goes to the e-commerce website and they're able to say, oh, I want this thing delivered today. And they wanted to be able to show them a range of delivery slots, and they needed to work out what delivery slots were available. They had to do a query that went and worked out, well, what couriers have we got available? So they're like a layer on top of couriers. So what couriers are available in your area at the moment, and have got space for the particular size of the parcel that you want delivered. And they were finding that just coming up with the result for one delivery slot, so i.e., for example, I want something delivered between 10 a.m. and 11 a.m., that was taking 2 seconds, which was a bit of a problem because they wanted to be able to show up to 20. So they wanted to be able to show the whole day's worth of slots that were available, and perhaps tomorrow's ones if today wasn't suitable. And so they needed to figure out a way to solve this problem. And in this case, they actually did this as part of a bigger architectural redesign. So they started off with this quite simple diagram here. So they had the person on the left-hand side makes a request for a quote, and it went into a Rails monolith sitting in the middle, which was interacting with the relational database, and then you'd get back your result. And as I mentioned, this was taking 2 seconds per slot that they wanted to show. And so actually part of the design was actually to break this up into services or microservices, I suppose it would be nowadays. And they came up with 3 main ones. So they had a quoting one, a booking one, and a feedback one. And the goal here for this particular for the Neo4j use case was how can we improve the performance of the quoting use case. So this is what the new system looked like. So they've got they've now got the quote comes in, and this time it's only interested in the quoting service. So booking and feedback are being served by in a different manner, and the quoting service was working with a Neo4j cluster sitting in the middle. although the booking and feedback services were still being written into the relational database, and then an ETL tool was being used to write in new data every night. And then during the day, there might be things that change. So, for example, when they got bookings, they'd update that in the Neo4j database. So there's still a little bit of real-time updating, but it wasn't coming directly from the user. It was kind of coming via one of the services. And so this worked quite well for them. So even though they were only using Neo4j for just that middle tranche of the work, it was really helpful there. And so instead of having this potential 80 second time window to show all the slots, they were able to get it down to 80 milliseconds instead, which is much more suitable for their use case. And the other nice thing that they weren't necessarily expecting, but which Cypher provided them, was that it reduced the complexity of their code. And so, like I mentioned a bit earlier, they were able to reduce the number of lines, and it was much easier for people to pick up. And so, as with the Telenor case, we've got a quote from Volker, who was the lead on the project and is now a member of technical staff at eBay. Okay, so that's our secondary store case, and there's a couple of other ones, other users. So one of the world's largest courier service uses it in a similar manner as well. So although the domain is different, well, it was not quite exactly the same. So this time it's a hierarchical routing system. So this is parcels coming into the actual system. So it's actually we need to figure out how do we route that parcel? What route is it going to take to get to its destination? So it's a little bit lower down the stack. And so the problem was that they realized that they were going to have a whole load of packages to deliver by Christmas, and it wasn't going to happen. So effectively, Neo4j came to the rescue for Christmas 2013. For some people, we like to say. And again, here the goal was, or the value of it was, we minimize the time to work out which way does it route, which means we can get higher throughput on parcels going through that service. And also the way that it was able to maximize the usage of the road network was an additional benefit for that.
Great. Yeah. Let's. In the final architectural pattern that we see is very similar to the secondary store in the sense that it's not the main. Well, yeah, it is the main actually, but it's not the original source of the data. So it integrates information from different systems. And depending on the purpose, we can categorize that as a master data store. If it's used to provide the reference data for other operational systems, or maybe an operational data store if it's used to run additional operations on the integrated data. We see that being in use. Well, we mentioned there's some European government agencies, but we give another example of manufacturers and retailers. So, what's the traditional master data store? MDM architecture. So you have a number of sources of operational sources of data that you ETL into your operational data stores or into your master data store, and then typically also use this information to ETL it finally into your enterprise data warehouse, use it for reporting or even operational BI. Or in the case of master data, you broadcast that to your operational system as the provider of master data. So what we're seeing is that our customers are replacing these operational data stores, these master data stores, with Neo as the graph database because of its flexibility and the new possibilities that it brings, like real-time analysis of connected data. So once you bring data from all sources and you implement the logic to connect them, you can traverse that data and get insights from it by doing this connected data analysis. And who's using that? Well, we have as an example, well, we mentioned, of course, we cannot give much more details on those, but some government agencies in Europe. But there's Slice, this toy manufacturer in Germany, who needed to bring together information on toy parts. It's a toy manufacturer, I believe I said, yeah. And they were integrating, as I was saying, toy parts. They were integrating country-specific regulations, materials, information from the suppliers, and they needed to build this product management system, which basically handled the master data for the products, and well, they managed to within 6 months to construct this platform and have the data migrated to it. So originally it was based on a as I was describing before, on a relational operational store, which was unfit because of its lack of flexibility for the requirements. And we also see it being used by Adidas in a slightly different context. They use it as a metadata store, and once they have this integrated data, they use it to drive content personalization on their website. So that's well, two of the most interesting customers applying this architectural pattern. We've mentioned in most of them applications running on top of Neo or middleware, integration middleware, either loading data Neo or extracting data out of it. So we thought it would be interesting to talk about what are the main integration surfaces to access the graph database. So we describe, Mark has described Cypher, the query language. So that's there's of course the possibility of interacting with the database using Cypher, and in that space we have the options of using the transactional REST endpoint that takes Cypher statements basically.
Yeah, and then that one's gonna, yeah. So that's the current view, I guess, in 2.3, and then from the 3.0 series, there's a whole new protocol that you can interact with, and there'll be specific drivers that are all very similar to each other, interacting through the Bolt protocol via Cypher, and that will effectively simplify this top bit of the slide, the Cypher integration bit.
Right, and there's we mentioned JDBC there, which is basically a wrapper on top of this REST endpoint, because it's particularly useful when you're doing integration using probably standard ETL tools. For example, you're a talent user, informatica user. Well, that's a quite convenient way of either reading or writing from Neo. There's also the possibility of the database is written in Java, so that there's the possibility of writing server-side code as well. So this notion of extensions that will be granted as procedures from the next version. So that's another option. So you can write your data ingestion and query logic as server-side code that you expose as REST endpoints again, and that's on the transactional side of things. But there's also the possibility of for initial populations of the graph, where you want to run a massive batch insertion as an initial data load. You can use facilities like the input tool or the batch inserter. You can find details of these in our website. So
now we thought we'd have a quick look at, well, what path do people take when they're adopting Neo4j? Where do they start out from? I don't think this is probably not specific to Neo4j in any way, but the starting point tends to be that somebody will get an interest in Neo. Will often have a particular problem in mind that perhaps they've been thinking about, and they're like, oh, that seems like a good one to play around with, and they'll build a prototype or perhaps a proof of concept, and at some point they might decide, it'd be good to get to show some of my teammates this, and then that might lead to doing a boot camp with someone from Neo or one of the partners to help sort of bring the team a bit more up to speed. So that'll often be the starting point, and then maybe you get to the point where you're like, oh, okay, maybe we can go and try this out, and perhaps you pick a particularly graphy problem. So often an opening one would be something where I want to add a bit of a social element to an application that I'm building. That's often a good starting point. And equally, actually, one of the interesting things is that we often see people starting out with one of those secondary data store examples, and perhaps they go. They get comfortable with operating Neo and querying it and figuring out how it all works in that secondary store. And then once they're comfortable with that, perhaps they then move on and use it as a primary store for a problem. So that's the path. And obviously, if you get stuck at anywhere on the path, then feel free to ping Jesus and I. We can probably help you out. So Neo has moving on. Neo has two different versions. So there's a community version and an enterprise version. And so these are just showing some of the features that they have in common. So the sort of main part of the database and the query engine is the same in both. So both use the model. They both allow you to work with ACID transactions where either you get the whole thing committed or you get nothing. They both have Cypher interaction. They both have allow you to use drivers for different languages. So we have drivers for PHP, for Ruby, for Python, for Java. And you can see some of the other features on there. And then the enterprise version distinguishes itself on operational features. So, for example, you can run it in a cluster, and it works with a similar replication model to MySQL. Effectively, you're shipping transaction logs around. And then there's monitoring, so we allow you to integrate it with monitoring tools. So, for example, the ones that we use internally are Ganglia and Graphite. Those seem to be the most popular ones, but there's scope to be able to integrate that with your tool of choice as well. And then there's the ability to, as for example, property constraints sit in the enterprise version, and you're able to trace Cypher queries as well. So the rough idea is, if you're prototyping with something or just playing around with it, and you want to run it on a single server, community is a reasonable place to start with. But once you want to get towards production, you actually want to run something, and you want to be able to sort of run it in often a web environment and be able to handle one of the machines failing and failover kicking in. Then you want to move over to the enterprise version of the software. And there's people in Neo that you can contact to talk about the differences between these. This is just a broad introduction so you can have an idea of how this works. So next, I thought we'd have a quick look. What does the ecosystem look like? So this has been growing sort of quite rapidly over the last couple of years. And so the easiest thing to do is see how many questions and answers there are on Stack Overflow. But in particular, there are also lots of people coming up with ways of integrating on the left-hand side with other data stores. So, like for example, there's a Neo4j Elasticsearch tool. There's one that allows you to hook up with Mongo. There's another one for hooking up with Cassandra. There's a tool that allows you to integrate with Spark, so you can go run some Spark jobs on a particular part of your graph and then write the results back in. There's several cloud hosting platforms. If you don't want to host your own stack, you can deploy it to one of those. There's a DB migration tool. If we come over to the right-hand side, there's loads of graph visualization tools. So there's so many. I don't think we could fit them on the page. So we've just picked 3 of the most popular ones, and that's a very common thing that people are interested in when they start coming across graphs. They're like, oh, I want to see what this thing looks like. And actually, a reasonable starting point is actually to download the Neo4j, just Neo4j itself, and have a look what the browser comes up with. That's got a D3-based visualization. If we go further, you've got application frameworks that you can actually build on. So there's Structure, which allows you to build a content management system really easily. And so they have a lot of tools that will solve a lot of problems that you come with around there, and you can just kind of plug that in. And then there's a graph-aware set of products which solve various problems. So, for example, they've got a tool that allows you to build recommendation engines very quickly. And so then there's other products, and we've got a link on there. And we'll obviously send out these slides, so there's no need to memorize.
Yeah, probably worth mentioning on the BI side, the integration. I mean, there's these quite popular tools like ClickView or Tableau that that don't offer necessarily a graph exploration tool like the ones that Mark has mentioned, but it's also interesting to see that they can integrate easily with Neo, and that's more in the context of we were saying before, like linked data BI if you want, so you can run your queries and return tabular structures, data sets that you can analyze and explore with ClickView and Tableau. So that's also a possibility. So the ecosystem is quite large. So it's
yeah, it's always growing. So there's often be a new project popping up that you can go and have a look at. So this is just a sweep of some of the ones that Jesus and I found on our travels. Okay, so right, let's just have a quick look about getting the team up to speed. So it's pretty similar as you might imagine. So we do training courses for various different levels. We kind of sit like a sort of intro to graphs, there's graph modeling, there's training for system integrators, and then we run meetups all over the place. So hopefully, regardless of the country you're in, you'll be able to find something that will get you going. And then there's obviously consulting services, which you can talk to Neo or our partners, which is the next slide. So we've pulled out on this slide a few of the UK ones, and some of these ones are also across different countries as well. There's a page on the Neo4j website where you can find more about that. And as we've been talking across the whole thing, there's lots of ways that you can get yourself up to speed with Neo. So there's Graph Academy, which sort of hosts all the different training. We've got Stack Overflow. There's lots of free PDF books that you can grab a copy of to get yourself up to speed. And then, as I mentioned, there's meetups. There's an online training course, and then we've got the concept of a graph gist, which you can look up and see lots of different models that people have been playing around with.
Yeah,
I think this is. I don't think we're going to go through this because I think we've got telling us that we've got
questions waiting for us.
We've got quite a few questions, so we're just going to quickly breeze through this. So there's lots of adoption in lots of different categories. So you can grab a copy of this from Corey tomorrow and maybe have a look through. And if you have any questions in particular about any of these, or if they're different than the ones that we looked through, then obviously feel free to reply back. And these are just some of the categories that we've seen people working in. And equally, if you've got any questions for either of us beyond what we're able to answer in the next 5 or 10 minutes, then there are our email addresses.
Good. So over to you, Corey.
Perfect. Thank you guys so much. Thank you for that excellent presentation. We do have a ton of great questions coming in, so thank you so much, audience, for submitting so many questions. You can continue to submit those, and if we don't get to answer them live, we'll go ahead and email you a response. So we'll jump right in. The first question is, how does Neo4j cope with more complex types? Would you recommend coupling Neo4j with a doc store like MongoDB?
Right, so yeah, we actually, Mark has mentioned probably this question right before we mentioned one of the integration possibilities. So we see that practically any solution these days will rely on more than one store. So this idea of polyglot persistence, right? So it's quite a common pattern where we see Neo working side by side with other type of stores, relational document stores like Neo. And yeah, I mean there's a project that integrates both, and that's a quite frequent pattern, I would say.
Yeah, and then I guess the use case really where you want to use both is where you've got very complex documents, perhaps with quite a steep hierarchy, lots of nesting. That's the one where you really get the advantage of having the document and graph together. But if there's only a few levels, then often we'll see people go, oh, well, actually, I can. No, it's not. It's maybe a little bit more complicated, but it's not too difficult to model the whole thing in a graph. But yeah, equally, we've kind of seen people do both approaches.
Great. The next question is, given mutability of graph, how can reshuffle connections when updating an existing graph with new nodes?
So I'm assuming this is perhaps referring to the refactoring that we mentioned. Connections or the relationships in the graph are immutable. So you can change properties on them, but if you can't, for example, change the name of a relationship. So if you wanted to create a relationship with a different name, you actually have to delete the existing relationship and create a new one. But you can do that whole operation in one transaction, for example, through Cypher. And so it wouldn't be possible for someone to see kind of the in-between state when you're moving between them. And the IDs that are used by those relationships are then reused, so that the next time that someone perhaps created a relationship, they would reuse the ID of the one that you just deleted. And so that tends to be the way that, I guess that's the way that things are reshuffled.
Great. All right, our next question is, what language SDKs are available for connecting to Neo4j, for example, Java, .NET, iOS, Swift, etc.?
Yeah, again, we can probably refer to our website, but basically, I can't think of a programming language that will find a driver to connect to Neo. So all the ones you mentioned and many more, like Python,
Ruby, Scala, Clojure, R. Yeah, R is quite a popular one. People are are quite enthused when they realise that there's a bit of R integration and they can hook that into their analytics toolkit really easily.
All right, great, thank you. And the next question is, if you determine you have a duplicate node, how could you merge them so the connections recast?
Well, again, this is logic that you can easily express with Cypher. I mean, that will be one of the ways. Actually, that's a quite common pattern. I mean, there are some use cases where it's about aligning, for example, two hierarchies, and once you have your logic that determines according to whatever your rules of similarity that two nodes are the same, you can merge them together into a single one and then migrate all the properties. It is similar to what Mark described before. So it's a very common case, I would say, and it's something that you handle very easily with the expressiveness of Cypher. So.
Yeah, so it's effectively just another refactoring query. Yeah. One, the first part of it, and so perhaps we haven't really delved into Cypher so much in this talk, and that wasn't the intention, but it allows you to do read time sort of exploration of the graph, and then combine that with mutating operations as well. And so for that query to merge two nodes together, you'd have a first part of the query that might go and look up the nodes and find all the relationships and the properties of them, and then you might create probably what you would do is actually choose to keep one of them, and you just go and delete the relationships from the other one and connect them into the one that you chose to keep. And again, you can do all that in one query. It wouldn't be
and it's important probably to mention that because of the we've insisted several times that Neo is a valid transactional database. It's ACID compliant, so this kind of query that involves a number of changes, I mean, it's guaranteed to either terminate successfully or not. So it's a transaction, whether it won't leave you in any inconsistent state. So you're guaranteed that you get the result of your merge, as you describe it here, and in a consistent manner.
All right, great. Since we are pushing up against the hour, we'll take two final questions, and the rest we'll respond to personally via email. So here we go with the second to last question. Do you provide any automated tools for migrating from relational database structure to Neo4j?
So at the moment, I don't think we have an automated tool that does the whole thing. What we do have is two very easy ways of loading CSV data into Neo4j. So Jesus has already mentioned that there's an import tool, it's kind of an offline import tool for initial loading, and it was intended for relational database dumps. And so it is reasonably easy to go, hey, I've got this relational database, I just want to dump these tables into CSV files, and then you could then write some code, well, not really some code, some configuration to load that into Neo4j. So that's the Neo4j import tool. So that comes, if you download Neo4j, that sits in your bin folder, and it's called Neo4j import. And then for smaller data sets, so perhaps if you're prototyping something, there's a command in Cypher called load CSV, where you can express a query where you say, hey, I want to load a CSV. By the way, this is where the URI is, and then I want to perform these operations to create a graph out of it. And I think we are actually working on a project to automate this, but at the moment, that's what is available is going to CSV and then getting it in that way.
All right, excellent. Our last question is there a way to handle large volumes of data, and do you provide distributed system kind of architecture?
Well, yeah, I mean, Neo itself scales to I don't know what the hard limit is at the moment, but to the billions of nodes and relationships. So in that sense, we find it very unusual that our customers find a problem in terms of the large volumes being loaded into Neo, and you can deploy. I mean, we very briefly mentioned it during the presentation, but Neo can be deployed in a cluster configuration that not only provides high availability, but also scales the throughput, the read throughput that you can offer. So in that sense, yeah, you can scale and deal with large data volumes.
Yeah, I haven't had many people having that as a problem they were coming across.
Yeah, don't know if we have time for one more or if it's.
We hit the hour.
Yeah, we hit the hour.
We have hit the hour. We're actually just a few minutes over. So what I'll do is we've compiled all of the questions, and I will send them over to Jesus and Mark, and we will respond back to you personally with to the email that you used to register for this presentation. So I want to thank you, Jesus and Mark, for that excellent presentation, and I also want to thank everyone so much for joining us today. Look out for our follow-up email. We will send you some relevant information to this topic, and we will also send you a recording of the presentation as well as the slides. And if you'd like to sign up for any future webinars, you can go to neo4j.com/webinars, and all of our upcoming presentations are listed there. So thank you again so much for joining us, and we hope to talk to you soon. Thank you.